Today we're going to be looking at this 2007 Buick Lucerne. We're going to be using a voltmeter and a scan tool to discover if this has a single range or dual range ECT circuit. On this section, the ECT is located right below the thermostat housing, right down here.
To get the voltage reading, we connected the voltmeter in line with the connection for the ECT sensor, which is right there.
So before we perform our test on the vehicle, I thought I'd show you the basics here on a piece of paper. Here we have our PCM, here's our digital multimeter, and here's our ECT sensor. This multimeter is connected to the positive and ground side of this ECT sensor, and we're going to be closely watching the voltage and then later measuring the resistance of it. This voltage reading we're going to see is the same that the PCM sees after it passes through the resistor or both. And then we're going to be watching that voltage reading as it relates to temperature. And we're going to see the voltage will start to go down because the resistance will go down of the sensor, since this is a variable resistor. And then we're going to watch to see if the PCM closes this transistor or if it has one. Because if it closes that transistor, it will allow a path of lesser resistance. See, this is 1,000 ohms, 10,000, so less resistance, so more voltage will be able to come through. And we're going to be watching for a voltage spike. The reason why we'd have this dual step is so that at higher temperatures we can have a more accurate temperature reading. So we're going to be watching the voltage as it relates to temperature and watching for a voltage spike. So as it warms up, we're going to see this number increase, we're going to see this number decrease. Then at about 120 degrees or so, if it has a dual step ECT, we're going to see this voltage reading spike about 3.9 or 4 if it has a dual range.
Right now, we just turned the key on and connected the scan tool. Right now, it's reading 68 degrees for the coolant temperature, and the voltage is at 2.333. Now we're going to start the vehicle so we can watch the numbers change on here.
Notice our voltage is starting to go down. So as the engine's starting to warm up, we're going to watch for a voltage spike to see if we have a dual range ECT. There it was. So the voltage just spiked up to 3.6. So now we've entered phase 2 of the ECT system. So now the reason why it spikes up in voltage is so that it can have a more accurate temperature reading.
You can see as the temperature is increasing, the voltage is continuing to go down. It's slowing down a little bit because it's at almost at normal operating temperature.
So now at right about 200 degrees, we've reached normal operating temperature, and so our voltage now has settled at about 1.8 volts. So now that the engine's warm, we could look at our chart here. You can see right about here. So we can actually turn off the engine now and check our ohm reading of our engine temperature sensor and see if it's within this spec or around there. So that's what we'll go ahead and do. So now we're measuring the resistance of just the engine coolant temperature sensor. It's just running into the meter, and we can see it's at 200 and around 20 ohms, which we can see is right where we should be. At 118 degrees, we saw our PCM power this transistor, which allowed more voltage to pass through the lower resistance, and that accounts for our voltage spike.
This is a visual representation comparing the voltage versus the temperature values. In our test, we were able to see when the car reached about 118 degrees, that's when you see the switch point and the change in voltage.
So here's a quick summary of the ECT sensor. As we saw, the voltage changed very quickly, and it was a nice, easy graph, and it'd be easy for the PCM to understand that. Once it got to about 120 degrees, it was very hard to discover a difference between the readings. So that's why once the PCM powered this transistor and lowered the resistance, allowing more voltage to pass through, that's why we have this switch point, this step, phase 1 and phase 2. That allows the PCM to see a noticeable difference in increased temperature. So that's a quick summary of dual range ECT sensors.